In this video, the objective is to find the limits of a function at the boundaries of the domain of definition. We are given the function f of x equal x minus 3 over x plus 1. We have to find the domain of definition of this function. The condition of existence for a rational function to exist is that the denominator cannot be equal to 0. And then the condition of existence is that x plus 1 cannot be equal to 0, then x is not equal to minus 1. So we have to accept all values of x except negative 1. So the domain of definition is all real numbers except negative 1. But because we want to study the limit at the boundaries of the domain of definition, it's preferable to write the domain of definition as interval form. So from minus infinity till minus 1 excluded, and then we continue from minus 1 also excluded till plus infinity. And this is the domain of definition. Now we have the domain of definition. We want to study the limits of the function at the boundaries of the domain and to deduce the asymptotes if they exist. So I need to study the limits of the function at 1, 2, 3, 4 boundaries. Minus infinity and plus infinity, at negative 1 minus, yani it means to the left of negative 1, and at negative 1 plus, it means to the right of negative 1. Now let's first start by the limit of the function at infinity. I'm going to say at infinity, and then we decide if we need minus infinity and plus infinity. So the limit of the function at infinity is the limit of the rational expression when x tends to infinity. We said before that if we have infinity over infinity, it's not determined. So in this case, because I'm having the limit of a rational expression at infinity, I have to think about the limit of leading terms of the numerator and leading term of denominator, which is the limit of x over x. And by simplification, we get that it's equal to 1. Then the limit of the function as x tends to minus infinity is 1, and the limit of the function as x tends to plus infinity is also 1. Because the limit of the function at infinity is equal to 1, then y equal 1 is an horizontal asymptote. Since minus 1 does not belong to the domain of definition, so we need to study the limit of the function to the left of negative 1, it means at minus 1 minus, and to the right of negative 1, it means at minus 1 plus. First of all, what do we mean by minus 1 minus? Minus 1 minus, it means to the left of negative 1. It's a small number before the negative 1. Okay, what is x plus 1 as x tends to negative 1 minus? I have negative 1 minus 0.0001, for example, and then I add plus 1. The minus 1 and the plus 1 will be simplified, so I will be left with minus 0.00001, which we consider it as 0 minus. It's a number before the 0, a small number before the 0. Now to study the limit of the function as x tends to negative 1, I can replace the numerator by negative 1. Whatever is the value of the numerator, we don't have any problem. But for the denominator cannot be equal to 0. So I replace the numerator by negative 1. The numerator is minus 4. In the denominator, I cannot put minus 1. I know that from this step that it's going to be 0 minus, because as x tends to negative 1, the x plus 1 is approaching to 0 minus. And I will have the limit of the minus 4 over 0 minus, which is nothing but plus infinity. Now the same for the limit of the function as x tends to minus 1 plus. Minus 1 plus means epsilon after the minus 1. It means any small value after minus 1, to the left, to the right of minus 1. If I take the value of x plus 1 as x tends to negative 1 plus, it is negative 1 plus 0.00001 and then plus 1. The minus 1 and the plus 1 will be simplified. The answer is 0.00001, which is 0 plus. If we replace x by minus 1, the numerator is negative 4, the denominator is 0 plus. And when you have a negative value divided by 0 plus, it is plus infinity. Now, to deduce the asymptote, we have to look at both the limit of the function as x tends to negative 1, it is plus infinity, and the limit of the function as x tends to negative 1 plus is minus infinity. And therefore, because the limit of the function as x tends to negative 1 is infinity, then x equals negative 1 is a vertical asymptote. Thank you.